Right, welcome back, smart mathematicians. The graph of h of x. Remember, our equation is h of x is equal to negative x cubed plus 6x squared. Right, the graph has the turning points at the origin and at B. A is an x-intercept of h. Also remember, we have the coordinates of A. Right, for which values of k will negative x minus 1 cubed plus 6 x minus 1 squared minus k is equal to 0. Have one negative and two distinct positive roots. Right, I want us to discuss just this concept. Is a common question, this one. It's a very, very common question. So let's just discuss it before we answer our question. So when you get such a question, what do you do? Right, let's say we have our h of x is equal to negative x cubed plus 6x squared. Right, let me use our function first before we come to this function, which is what? Translation. Right. So if I say maybe for which values of k, when you're given that negative x cubed plus 6x squared minus k is equal to 0, and I say for which values of k will this equation have, maybe say, three distinct roots. What do we do? Okay, you have to equate your function to k. So we say here negative x cubed plus 6x squared is equal to k. So you transpose k and bring this side. And then, for example, let me say the k value is 2. How many roots are we going to have? If, let's say, we have negative x cubed plus 6x squared is equal to 2. So if, say, k is 2, how many roots do we have? What do we do? So let's say this is our 2 here. So it means 2, this is the horizontal line. Okay, which is equation y is equal to 2. So it is 1, 2, 3. See that? It has 3 distinct roots. What if k is negative 1? Let's say we have negative x cubed plus 6x squared is equal to negative 1. How many roots do we have? Negative 1 should be here. You see that? This would be y is equal to negative 1. So you have only one root. You see that? Right. What if maybe negative x cubed plus 6x squared is equal to 33? 33 is a power of 32. You see that? So this would be y is equal to 33. So you also have one root. Now, so if I say for which values of k will this equation have what? Maybe 3 distinct roots. It means our k should be between what? Should be between 32 and 0. You see that? Because between 32 and 0, that's where we'll have 3 roots, something like that. You see that? So always equate your function to the k value and then try to interpret after doing that. Okay. Right, let's come back to our question. Here. For which values of k will this function, you can see it, minus k be equal to 0? So let's write it like the way I said we must do it. We say, let's say negative x minus 1 cubed plus 6x minus 1 squared is equal to k. Right. What do you see here? What do you observe? If you compare this new equation with this equation that we have here, remember our equation is h of x is equal to negative x cubed plus 6x squared. You see that? So what has happened here? X has been replaced by x minus 1. What is the meaning of that? Okay, so it means now we have f of x minus 1. What is the meaning of that? Meaning of this? It means the graph is shifted 1 unit to the right. Okay, the graph is shifted. This is a translation. The graph is shifted 1 unit to the right. So it means it's something like this. We have our graph, then it's shifted 1 unit to the right. Now, we want a situation where we have 1 negative and 2 distinct positive roots. So it means this should happen here, where between these two lines. See that? This is where we have what? 1 negative and 2 distinct roots. 1 negative and 2 distinct roots. You see where I've put roots, the dots there. Okay? Right, now, so it should happen between what? Between which values? Here we know that y is equal to 32, but we need to find this value here. So how do we do that? So here we know at this point here, x is equal to 0. Along the y-axis, x is equal to 0. So we put 0. Where there's x, we put 0 into the equation. Okay? Where there's x, we put 0. So let's say we have h of 0 is equal to, so it's going to be negative, and then 0 minus 1 cubed plus 6, and then 0 minus 1. You see that? And then becomes, this is negative 1, because negative 1 cubed is negative 1. Negative 1 times negative 1 there is positive 1, or squared here. And then negative 1 squared is 1, and then it means 1 plus times 6 is 6, so it's 6. This means there is 7. So it means this point here is 0, 7, meaning that here y is equal to 7. So it means here, so for which values of k will this function or this equation have 1 negative and 2 distinct positive roots? When k is between 32 and 7. So it means when k is greater than 7 but less than 32. Okay? Right. So, or you can say when k is an element of 7 to 32. That's when we'll have 1 negative and 2 distinct positive roots. Okay, let me try to use the blue line here. You can see 1 negative here, and then 2 distinct positive roots, something like that. So it means our k value should be between 7 and 32. Okay, all right. So that's what you're supposed to do there. We can interpret this one differently, but I think this way will make you understand. But the more questions we're going to be doing, the more you're going to understand. Okay, let's keep trying. We'll meet in our next question, which is question 11.